Hello everyone. Today you are going to learn how we can create pie chart, histogram and box plot in R. So basically in pie chart we are going to show let's say we have a percentage of some variable. If we have categorical variable, so for all those categories how we can better visualize them. So that's where pie chart comes in. So for categorical variable we'll be creating pie chart. For numerical variables we will be creating histograms. Also for numerical variables we will be creating box plots. So I gave you the RMD file same as before and the output file, that means knitted in Word file, and then only one data set we are going to use. We are also going to use an R data file. So what is actually built in R. So let's see what we have in our lecture slide. So at first we started with the pie chart. So in the pie charts we especially are going to show the proportion of values of categorical variable. So let's say you saw that we have the species variable. So in the species variable we had few species in the data set in the VRI data. Then we said that we would like to show the those frequencies that we have in each species, or you can say no, I would like to show in percentage. So we can show in percentage, that means in each species category what's the percentage. So you can see the higher is in CW or HW, and then lower is in this DR species. And then we can also add a box around it. So let's see in R how we can write the code. I gave you the code in here, but you will see that in R Markdown I also gave you codes for creating pie chart. And let's open our studio. In our studio R Markdown, so let's see. So let's bring in the data first. So I already brought in the data after by running this line. So I just say that we have the data, and then you can also use D1 and D2 dataset. I gave you this dataset as well, so you can change your code so that you can also see only for D1 and D2. And then for creating pie chart it should be categorical variable. So you can see at first I asked what's the category of these variables, species CD1, and then if I say plot species CD1 without specifying anything what kind of plot, you can see it plotted just what we did before, bar plot. That means it knows that it's a categorical variable, and categorical variable can be plotted as bar plot or pie chart. So if you want to create category, you want to create the pie chart, all you need to do is that you have to create a table. That means we would like to create a table of species CD1. So you can see if I only select that, so it's creates a table of species variable. That means in each category how many observations are there. But it would be better if we create a percentage. That means in each category what is the percentage of observed values. So you can see the percentage would be lower in DR, and then higher would be in CW species. So I just created a percentage. So let's see in percentage, if you run this line and then if you only ask to show this percent species, so you can see we have the percentage, that means 42% is coming from CW species, and we also have missing information about 2%, and the PLC 6%. So that's how it shows the percentages. Then I say that create a pie chart of the table we created before. then you can see it's giving me a pie chart. That means only for leading species. But if I want to show the percentage of species, then I have to use that percentage table. After the table, I added the title. Title parameter is same as before. So you can say I used main. That means I added a title in there. And if you want to add more, let's say you want to increase or decrease the radius. Radius is from the center to the border of this circle. If you want to make it larger, you can add that. Let's say radius is 0.5. That means I reduced it. You can see it's way too small. Let's say 0.9. Then it will be back. You can see. So that means we created a larger radius. So if you want to add a box around this pie chart, you have to write this box function and then you have to run it together. It doesn't work separately. So we added a box around it. If you make it way too large, let's say 1.2, you can try that. But there it might go beyond. That means we made it way too large. 0.9 was better. That means it's adjusted within this box and within this graph area. And we added a title. Let's see on the web how it's look like. So I created RStudio project. Within the project I brought the data, VRI data, CSV file and R Markdown file, and then I open the R Markdown file and I already ran the VRI data, so VRI data is already there. But only problem you will see is that if I run this class, no problem in there, it says that it's a character variable, and then only problem is that if I ask for plot that variable without defining it, it gives me an error. That means ask for while limit. So only that's the only difference online. So you can just keep it in as a comment or remove it, and you can try running these. So you can see we created the leading species of stand, and then previously we created without the box, and then we also created without the title. Then so you can also use 0.9 in here. Then oops, so let's say run this selected line. And run the entire chunk. You can see we have the leading species and then all of them are there. Okay, so let's go for the next item. The next item we have is the histogram. So we try to see the distribution of one variable. In scatterplot we use two variables in x-axis and y-axis, but in histogram, pie chart and bar plot we use only one variable. That means we would like to show the distribution of the of one of the variable. So over here I selected the age variable, you can see, and I would like to show the distribution of age. So we created the distribution, and then you can see the bars we have are joined because it's a numerical variable and we have continuous information. So let's see, in the histogram when we create the distribution we can create in two ways. We can say show me the frequency of the age values, or we can say no, show me the percentage, that means the probability. So if I say histogram of which variable, and then if I say frequency is f, that means frequency is false, it will give me the probability or the percentages or if I say probability is true, it will directly give me the percentages. So let's see if we want to add more information. So let's say within the histogram we want to add how many bars should be there. So if we say give me less bars, so you have to say breaks equals to how many and what should be the limit of the y-axis. Then you can keep everything within that limit. And if you say breaks, so you can see 1 2 3 4, there are 4 breaks in here. Okay, and if you want, you can add more using other data set as well. So let's go back to our code and let's see where we were. So in here okay, so before we create histogram in the R code, you will see that I gave you a name of the data, faithful, and faithful is a data, but we don't need to load it in here. I don't need to give you the data set because it is already built in our environment. That means R is giving us some data that is already loaded in R. So if you ask for the name of that data, that means the variable names. So you can see in faithful data we have two kinds of information, eruption and weighting. But what is actually faithful? So if you look for the faithful data, let's say see, and then in here let's ask for, let's ask it in here, let's ask for faithful, question mark faithful. So you can see we have information of the data set from Yellow National Park from USA, and they are giving us information of eruption and the duration of the eruption from Old Faithful Glacier. So that means we have two variable information, the eruption, that means the eruption time in minutes, and the steam water, that's the waiting time, that means when it comes to at the next time. So if you want to know more about this data set, and they also published a paper, you can look at this paper. If you click on it, it will take you to the paper. So we would like to plot the two variable. So I wrote faithful $waiting and then faithful $eruption because the names of the variables within the data set, it says that eruption and waiting. And if you want to see the entire data, you have to run the data set. So it shows you the variable information, the eruption, and then the waiting time. Waiting time is it says in minutes. So that means after 79 minutes we have the next eruption. And you can see we have the entire data set. So that means 272 rows we have. So if we want to plot them to these two variables, if you want to know whether there is any relationship between them, then you can say they are actually almost linear. That means if the waiting time increases, the eruption increases. So in here, okay, so that's the previous scatter plot we have. And then I created more plots so that I can add more information. So you can see it's way better, the x-axis and y-axis levels, and I also added the limits, and then I also added the title. So we will create histogram using this data as well. Okay, so over here, that's what we are interested about. In using the VRI data, we are going back to our data set. So we said that create a histogram of age only for one species. So I added this subsetting in here. So you can see I only asked for one species, and I said that in x-axis level what should be the level, and in the title we are not adding anything. So in this histogram you can see the bars are actually not within the limit. That means we need to increase the y limit, and we need to adjust the these how many bars should be there. That means how many divisions should be there. So you can see I added more, and then I added all the details just like we did previously, X limit, Y limit, and I also added the names and everything. So let's draw them. So in the histogram, I said that frequency is F, also frequency is F or T, and then how many breaks should be there, x-axis level. So you can see all those graphs. That means I actually increased the Y limit, I added the X limit, and then I said that this is in density, and this is in frequency, previously density, and then now it's in frequency. I use the faithful data as well. So that means the first one is way too many breaks. If you want, you can reduce the break. So you can see over here I reduce the breaks. If I reduce the break, we have less, 1 2 3 4. Sometimes you will see that it adds more because it needs to divide in equal form. So that's why if you want, you can say no, I want 10 breaks. If you add 10, then you will see we have way too much. So that means you need to make some adjustment. 4 is way better. In that way we can see the distribution you can see the structure. That means at first we have lower, and then in the middle we have more, and then later we have less. If we want to use the histogram, if we want to create histogram for the faithful data, then you can select the eruption or select the other variable, the waiting time, and then you can create the histogram. That means in histogram we only need to use one variable. And then at the end you can see I created the histogram, but I added the title, y-axis limit, and then I said that what should be the x-axis limit, and then and we can add the what would be the breaks. So if you want, you can add the breaks in here. So you can say breaks equal, let's say 6. It tries to adjust, may not be exactly 6, but knows that what we want. And then if we say less, then you can see it because now in one category it's way more, and you have to adjust that. That means Y limit should be increased. So frequency could be 120, let's say, because we reduce the number of bars. So that means not, let's say 200, too much, I know. That means it actually goes up to 100 and less than 150. So that's how we create. Let's go back to the previous ones. Okay, so we added less breaks, and then we added the Y limit. We need to adjust that. On the web it's the same. So you can see on the web we ask for the data set and everything, created the faithful data, and then you created the scatter plot, and then we created the histogram, all of them. So it's the same. So if you bar over, then you can see the first graph, second graph, and then how we actually added more, and how we added the percentage and frequency. Density is for the percentage. Okay, so the last topic for R we have is the Boxplot. So Boxplot is again for numerical variable. So in the Boxplot we actually summarize the data. We like to show the minimum value, maximum value, the middle value, and then what's the distribution, just like the histogram. So everything we can show in one graph. So you can see we created a box plot, and over here we are showing the what's the maximum value, what's the minimum value, and what's the median we have. So let's see what we have in this box plot. So over here you can see we created a quantile, that means the minimum value, maximum value. The probability is 0, probability is 100. So that means the percentages we are showing is this, the minimum value, that means on the 0% on the minimum level, what's the value we have, or that means what's the percentage, and then the median value in the middle what we have, and then if we have the 100%, that means the maximum value. So it actually gives us the quantile values of the data set of one variable. So you can see when we have the box plot what they are actually mean. So the maximum value is here. Sometimes you will see that it's showing this bar, but then it's not the maximum value. That means we have some value that's not behaving the same with the other values in our data. That means this is actually outlier, but that's the maximum value. And then minimum value, and then first quartile, that means within 25 percentile, what's the value we have within the middle value, that means median value, where is that? So you can see the middle value or the median value is about little bit more than 250. So that's how we are going to read a box plot. So in box plot we can say which variable you want to show, which either we want to show the age variable, and then what should be the title in that box plot, and in y-axis limit, what should be the limit. If you want, you can increase that, and then what should be the y-axis level. So, and then I also showed if we have age, but I would like to show for each species what's the box plot of age. So you can see I said box plot, but then again for age variable, and show me for each species. That means this tilde sign will show me for each species. Previously we added just one box plot. Now we divided this data for each species. So you can see in SS we have the largest age, and then median, that means the middle value is changing. Also in CW we have some outlier, that means these variable values are not behaving the same like the other data set. And then you can see the distribution as well. So you can draw a distribution just like histogram. So if you want to show less, so I showed all species in here, but over here I just selected 3 that I'm really interested about, these 3 species, and I just showed these 3, and for each of them I said that okay, give me the names as well the way I want. So let's go back to our code. So over here for box plot we have to start with boxplot function, and what's the variable we have? It just creates the box plot without any parameters. We don't have any title, we don't have any y-axis level, and then we need to increase the y-axis level. So that means if you want to see the quantile, what are the values, that you can see the values are 0 and then up to 543, and then we know the limit is 543, so we increase the limit to 550. And you can see we also can add some more parameters. So you can see I use box width. Box width is for increasing the box width, and then increasing or decreasing the box maximum lines. So let's show you what I meant by that. So box width, so if I increase this box width, that will, now it's 0.5. If I say 0.8, the box width will increase. So you can see it increased. If I want to increase this line and this line, then I have to increase here. So let's say 0.8 as well, and then we'll see it will increase. If you want it less, you can reduce the number. So previously we had 0.5 and 0.5. So you can adjust this, and I increase the limit to 550. So let's see. And you can say no, I would like to show until 580. That means more. So you can see it goes up to there. I increase because 600 is the best. That's how it's showing us. We wrote 580, but 580 it couldn't adjust, so it gave us up to 600. And then for multiple categories, you have to use the tilde sign, and then what's the multiple category for this species. So we added for this species. Now we say that we only want to use 3 species in our data set, from our data set. Then we subsetted them, and then we only showed 3 of them. And then you can add the Y level. So in the Y level we have the age. I did not add that, but you can add Y limit, and then you can also add the Y limit. So let's say Y limit is this one. You can add parameters anywhere. So I increased the Y limit, and then I added the Y level. Okay, let's go back to the pages. So I gave you the knitted word file, and then I gave you this code, and you can go to your RStudio Online, do the same. You can see we have these, and then you can adjust the parameter. You can add the y-axis limit, increase the y-axis limit, and then add the y-axis level. Also you can add x-axis level if you want. So that's it for today. That means we learned how we can create pie chart for categorical variable, and then for numerical variable we can create histogram, or we can create boxplot. So in the boxplot you can also draw a line. So if I draw a line like that, then you will see that we have a histogram. So let's say from the boxplot how we can create a histogram, as I mentioned. So let's open it on Paint. So if I join the lowest value and then draw a distribution, I know it doesn't look nice, so you can see that's the distribution. Or let's say I join the maximum value, and then you can see this is just like a distribution. You have to rotate that. And then for the other species I also created the distribution. So you can see we have the distribution of the 3 species. So that's what the histogram, in histogram we also create. So in histogram we actually create the, we divide into sections. So you can see we divide them into bars. Okay. So you learned from this lecture is that how we can create them. So if I ask you in the exam, create a histogram, or maybe what should be the code for creating a histogram of one variable. That's it for today. Thank you.